Hello, my name is Jeremy Dizon, and I'm really excited to be here at Schema alongside a few of my design systems partners in crime. We have Joanne Deng, who is one of our front-end engineers, as well as Michael Yam and Runi Goswami, who make up our designers triforce. We are just a handful of the Lyft Design Systems team that also includes our platform engineers across from iOS, Gabriel and Daniel, Android, Alex and Anton, and web, Eric, as well as our amazing and supportive leaders, Lindsay, Amanda, and Matt. For us, it takes a village to create and maintain our design system, the Lyft product language, or LPL for short. And we provided a peek behind the curtain in our User-Centered Design Systems Resources blog post that we published back in August. What most people don't know is that it took a year to write that blog post, not just because we wanted to be as comprehensive as possible, but design systems folks know that it's a journey to get things right. And in a way, the year we spent on this article reflects that journey. So why are we here? Well, we learned through our experiences that, like any other product, a design system is as useful as it is usable, which is why we take a user-centric approach to our LPL resources. Today, we're going on an adventure as system users, both designers and engineers, to deep dive into onboarding, documentation, libraries and tooling, processes and contributions, and support, to discuss the value each of these resources brings to a design system. To begin our discussion, I'm happy to hand it off to Joanne, who is representing all designers right now with the go-to black t-shirt.
Thanks, Jeremy. Hello, I'm Joanne. I'm a front-end engineer on the design systems team at Lyft. Now let's imagine it's your very first day at Lyft. This is what it would look like. We're showering you with LPL. Now obviously, this is an exaggeration, but the point is we want to expose new hires to our design system as soon as they start. This is why we closely incorporate LPL into onboarding for designers and engineers. Before we dig deeper into what our onboarding looks like, let's first understand what our primary goal is. We want our users to have a systems thinking mindset from the start. In order to achieve that, we first want to give users a high-level introduction of what the system is, why it's important to use it, and where to find resources. Then we want to make sure they feel confident with using the system before their first project. We want to teach best practices, whether it's Figma or coding best practices. We want to establish a culture of collaboration from the very beginning. And finally, we want everyone to be on a level playing field with tooling from the start. Our current onboarding process achieves all these goals, but it definitely took some time to get there. We initially had a lot of presentation-based onboarding, but when there's so much onboarding content, it's hard to keep the audience engaged, and it's hard for them to retain the content. If you're anything like me, you might have had trouble paying attention in class, but you learn a lot by doing assignments. We wanted a more engaging way to teach our users, so we created something called Sims, short for simulations. Sims is kind of like playing a job simulator to prepare for your actual job. What this actually looks like is, we have you go through this narrative where you're pretending to work on a project and you follow conversational prompts to discover LPL resources and learn about LPL. For example, one of the prompts is like, oh, you found a bug in this LPL component. What do you do next? Where do you get help? We guide you on finding the answer. You type in the answer into the sim, and we tell you if it's correct. Overall, we cover important conceptual knowledge like what is LPL, how to get help, and how to navigate documentation. As for how the sims are created, we use Qualtrics, which is actually known for being a survey tool, but we found that it works really well for our use case, which is a more conversational format. After completing the sims, users have definitely achieved the goal of understanding the system. But we haven't covered these 4 other goals here. They've never used the libraries and tooling hands-on yet, so they probably don't feel confident going to their first project. We also haven't covered implementation best practices and haven't established a culture of collaboration. If we stop with onboarding here, this is how users might feel during their first project. In order to achieve all the goals we were missing before, we created onboarding labs. These are hands-on exercises that walk designers and engineers through an example project while collaborating with a mentor. And while doing these labs, they get hands-on experience using LPL. For both design and engineering, these labs teach how to identify LPL components and attributes, how to use and customize them, and how design and engineering can effectively work together. This includes topics like engineering handoff, for example. Now, taking a closer look at our design lab, we have an exercise where designers follow step-by-step instructions to translate this pencil sketch into a Figma file. A major part of this is learning how to use LPL. Similarly, for engineering, we have code labs. Here's an example of the Android code lab, where engineers work with a mentor to fetch information from an API and display that information using LPL components. In summary, this is what onboarding looks like. Designers and engineers first complete sims to get a better understanding of the big picture, and then they dive deeper into implementation, where they practice using the system while collaborating with a mentor. By closely incorporating design systems into onboarding, our users are well equipped to start using our libraries and tools, and they're also well aware of how to navigate our documentation, which is actually the next topic of discussion. If you're a design systems user, you often ask questions like, when do I use component variation X versus Y, and what's the recommended way to place these buttons? The answers to these types of questions can be found in our documentation site, which is a centralized resource with tons of guidance. In fact, our designers spend the majority of their time writing guidelines when adding a new component to the system. The site is also the source of truth that keeps design and engineering on the same page. So whenever we add a new component or update an existing component, we immediately update the documentation so decisions don't get lost. As for engineering documentation, we have the typical information like props and usage, but what's more interesting is that we cover the accessibility details of our components. We highlight the best practices used to make the component accessible, and we also give tips on how to best utilize the accessibility features we built. We do this because we're really trying to raise awareness on accessibility across the company. So we try to sprinkle some accessibility on everything we touch. For live demos, we use Storybook to showcase web components, and for iOS and Android, we render demos in the Lyft app. We show examples of the different options available, and for some components, we demonstrate how it's built into a more realistic use case. For example, here, we're showing a demo of a sign-up form using our text field component. Users also look at the source code of our demos to see more complicated usage examples. I'll now pass it off to Mike to talk about design docs.
Thanks, Joanne. Hi, all. I'm Michael. I'm a product designer on the design systems team at Lyft. Next, let's look at some of our design docs with the lens of how we're answering some of the most common questions from designers. What component should I use here? That's something we hear all the time. Designers might go through the following process when trying to figure out what component to use. Let's say a button. They might start by looking at the Figma component library, which is a great place to start. Then, perhaps they'll jump over to the documentation site, and when they see there are 6 different buttons, they might feel a little bit overwhelmed and reach out for help on Slack. And lastly, they might just end up winging it and choosing whatever they feel fits best. This process could take them 10 to 15 minutes, or up to a few hours even, waiting for the design systems team to point them in the right direction. To address this ambiguity, we create decision trees with simple yes or no questions so that users can find the right tool for the job, or perhaps they might find related components they were unaware of to begin with, which better suits their needs. Compared to before, we've heard from designers that they can now make their decision within a single minute. Another question we hear quite often is, what can I do with this component? Which parts are flexible? And one of many ways we address this question is by including a detailed anatomy of our components in our design docs. We help users break down components into distinct parts and provide visual examples. Let's take a closer look at this component, which consists of a parent and an expanded area. Inside of the parent, we see that there are 3 flexible content areas. Without going into too much detail on the docs, we look at how the start area on the left provides flexibility for an icon. The middle area, which is required, has a few variations for the main text content, and the end area supports an interactive icon. We make sure to be consistent when referencing these areas, not only in this documentation, but also in Figma when we name the various layers or properties. Ultimately, our documentation should be a clear reference and source of truth for what you can do with a given component. Lastly, for documentation, we come across the topic of parity quite often. That's a big design systems buzzword, right? In our system, we support iOS, Android, and web, so it's important that our system is not only consistent across the board, but also meaningfully different in some scenarios. At Lyft, designers previously had been handing off their work using mostly native iOS paradigms, such as including chevrons at the end of list items. One way we address this inequality towards platforms is by including platform-specific considerations in our documentation when necessary. For instance, we call out that Android users don't expect a chevron icon to indicate tappability for this component. If you're in design systems, you love documentation, or maybe through it all, you love to hate documentation now after writing so much. Regardless, we all have the responsibility of creating docs, not just for the sake of it, but to create a reliable source of truth, to reduce time for support, and most importantly, to truly equip our users to do their best work. Our discussion about documentation naturally progresses us to libraries and tooling, another important resource for our users. When you hear libraries and tooling, you're probably thinking, oh yeah, Figma or Eng component libraries, we have those. But have you considered how these play a huge role in how designers and engineers can become better friends? Ultimately, the goal is to help users build quicker and with higher quality. Like many of your design systems, we do organize Lyft product language into Figma and engineering libraries, and we maintain these sources of truth. Now, we could focus on what our libraries look like, how we set up and organize them so that people can make actual use of the system. But today, we'll focus mainly on how our libraries and tooling are also instruments for collaboration and process between the design and engineering functions. First up, let's talk about trust and friendship between design and engineering. In any organization, we all know that design systems teams are hands down the most organized peeps, and I have absolutely no bias here. We like to clean up our messes, we Marie Kondo our Figma libraries, and it's a joy when everything comes together nicely. But in practice, it's just inevitable that partner teams deviate from the system and use one-off styles for type, color, or intentionally detach things to meet their needs. Sometimes it's a lack of system awareness, sometimes it's for speed. Either way, when this happens, it simply does not spark joy. When designers detach things in Figma, what follows is actually a disconnect in the collaboration between design and engineering. Updates to the system don't cascade or trickle down correctly. Engineers who usually look for system styles and components now have to go and figure out what parts are using the system and what parts are custom. Basically, Eng bears the responsibility of quality in order to fill in the blanks and troubleshoot the ambiguity. And lastly, all of this can lead to a break in trust in one another. To address these trust issues, we built a design linter that checks for missing LPL styles such as type, color, and elevation. It detects inaccessible colors and even presents a magical one-click fix button. But what's most important about this tool is how designers and engineers can now shift their time and energy away from fixing system bugs and instead collaborate more deeply on the user-centered details of the Lyft experience. Next, let's talk about how libraries and tooling also play a role in establishing a common understanding of the system, the source of truth. Design systems buzzword number 47 for the day. These are some questions that get asked all the time by our system users. While our libraries and docs give an overview of what's possible with the system, the reality is that not everyone gets it. Without a proper source of truth, designers and engineers find themselves being unaware of the system, creating features or experiences that are custom, hacky, or just not possible. Or worst of all, they might start the design process all over again after troubleshooting with design systems. Thankfully, to address source of truth, Figma has equipped us to structure and organize the components and variants to closely mirror what's possible in code. As engineers make use of props to configure components, as Joanne shared earlier, we enable designers to make use of properties to get the component variant they need. For some of the more complex components, such as data tables, we not only try to align with Eng and design, but we also carefully craft the Figma components based on usability tests with our fellow designers. We ask them to talk through their design workflow, which helps us uncover knowledge gaps and perhaps more properties and options for flexibility. As a result, designers are better versed in how the system works and can collaborate with Eng more purposefully and effectively. Instead of throwing a design deliverable over to Eng and just hoping for the best, they can work in a more agile manner, talking through how to use the components to create a great user experience. And lastly, dark mode. A lot of our user base relies on it, especially for drivers at night. And so we strive to test our experiences in both light and dark modes in all of our design and development environments. We created a Figma plugin that scans a selected frame for system colors and swaps between the light and dark counterparts with a single click. This helps teams see the actual darken mode experience early on in order to QA the color choices and ensure an accessible viewing experience. Lastly, with this plugin, we found that designers are actually now a lot more likely to use system colors in their work, which is a great benefit. It's also important for our engineering teams to test on dark mode to fix any bugs where colors are not showing as intended. Our mobile beta app includes a catalog of our system with dark mode settings, and for web, our Storybook demo site includes the same dark mode toggle. With these tools, design and Eng can collectively visualize the real color experience and ensure quality in both light and dark modes. And so when we look at all of our tools, we make sure that we're answering the question, how does this thing not only help make use of the system, but also mitigate holes in our process, improve cross-functional relationships, and push everyone to build quicker and with higher quality? Next up, Jeremy is going to give us a peek into some of our processes and the contribution model that he's worked on over the past year.
Thanks, Michael. Anyone in the design system game knows that setting up a good foundation is key. In order to create holistic solutions that will add value to all system users, we go through the process of creating a set of artifacts that ensures quality and consistency is built into everything that we touch. Those artifacts include a project brief, component audit doc, a review deck for stakeholder meetings, component guidelines, a Figma design file, and even a handoff doc that outlines additional information, like a motion spec. And this is our standard operating procedure, regardless if it's a new component, an update to an existing component, or product team contribution, which is the rabbit hole I'd like us all to collectively fall into right now. From a system user's perspective, we're often asked, how do I request a change? And how do I request something new? Normally, we tell them to fill out a request in Jira, and that ticket will sit until our team plans our roadmap, which happens twice a year. So not super ideal, right? We soon realized that we could leverage these requesters to help us update system components and make new ones too. And that's how our first contribution model was born. Though the motivation to firsthand add to the system sounded great, we needed to show that the process was valuable for everyone. We evangelized that LPL contributions allowed product designers and engineers to practice systems thinking, as well as make a greater impact outside their immediate focus area or feature. Design systems tried to establish a partnership with product teams, but it functioned more like a consultancy. As contributors worked through the concept phase of the product design process, we would provide thoughts and considerations focusing on the flexibility of what was being designed and built to ensure it supported multiple use cases and products. This put a significant amount of responsibility on the contributing product designer and engineer to not only design and build a functioning component, but also incorporate all the things that design system folks always consider, like color contrast, screen reader accessibility, incorporating established system patterns, as well as the dynamic type and dark mode experiences. From the design systems perspective, this hands-off approach made us feel like project managers, sporadically checking in with the contributor and waiting for the contribution to be complete. On top of that, the contribution process only documented quality and handoff checklists, but not how to best tackle design system projects like this. At the end of the day, we realized this model promoted the feeling that contributions took too much time and effort, especially when prioritized against product team roadmaps. So, how did we revamp the program? Well, we discovered that a lot of our problems could be solved through education. We knew a lot of system users don't realize how much effort is involved in creating a new system component. So we asked ourselves, can we leverage our existing artifacts to educate product designers and engineers not only to understand how we design holistically for multiple features, but also walk them through that process themselves in the form of a contribution? It's the classic two birds, one stone scenario. The short answer is yes, thankfully. Our rigorous process, supported by each artifact in our Batman utility belt, proved to be the foundation to teach others to think as we do. 10 points to Gryffindor. But that only solved one part of the equation. We needed to address that it takes too long to contribute conversation. Since we love artifacts so much, we leaned into that and created additional ones called playbooks that answered any and all questions around contributions. In each role-specific playbook, like this one for design contributors, we provide as much detail as possible, including the expected effort required to contribute, what they're responsible for, and what's shared with the LPL designer, an example timeline to illustrate the length of a contribution process, and a rundown of the steps from project kickoff to engineering handoff. These playbooks became our guides, not only during the project, but also to answer any questions a potential contributor might have. And in a way, became a working agreement between contributors and LPL, creating more of that partnership we were looking for over the consultancy model of the past. We also added fuel to the fire by advocating to our leaders to support contributions as a tangible step towards career development. Each contribution project is an opportunity for product teams to think outside their feature, to create a component or offer an enhancement that provides a larger impact to multiple teams in the company. And we were able to accomplish this by scaling our rigorous process and artifacts we use on a daily basis and apply it to the evolution conversation. Honestly, a lot of this work was successful because of how we engaged our system users. To further our conversation, Runi is going to talk about how we as a design systems team supports them.
Thank you so much, Jeremy. Hi, everyone. I'm Runi. I'm a designer on the design systems team at Lyft. And we really wouldn't have a system at all if we didn't have super engaged system users. So let's talk a little bit about how we support them. Allow me to get meta for a second. Us system folks are a weird bunch of people. We love reading and writing detailed documentation. We tweak our processes so often that we have processes for tweaking our processes. We are extra. Up until now, you've heard from Joanne, Michael, and Jeremy about all of the stuff that we have in the system and how we try to work really hard to make sure it's as usable as possible. But not all people are systems people like us. In fact, most aren't. From a system user's perspective, the system should be invisible. It should just work like they need it to. But inevitably, sometimes it doesn't. Over time, we've opened up multiple communication channels to make sure there are many ways for system users to get the help that they need from us. The easiest way by far is our Lyft product language Slack channel, which has a 24-hour service level agreement. We try to respond within a couple of hours during our East and West Coast working days. If users want some in-person time with us to get feedback on work or ask more open-ended questions, we hold weekly office hours by appointment and ensure that the right team members are there to answer the questions. And for bugs and feature requests, we have shortcut links to handy-dandy ticketed templates in our project management software that Jeremy alluded to earlier. As our system has grown bigger and bigger, and as the total number of system users has also grown, so have our support requests. On average, we actually spend a third of our time on support tasks. Collectively, that's about 160 work hours a week, also known as a heck of a lot of time. As you learned from Jeremy, we are process-loving weirdos, so we made a support playbook for ourselves to help tackle all of these tasks. That's right, we have help docs to help us help others. But we had to make a lot of mistakes along the way to get to this relatively stable state. In the early days of the system, we just had the libraries and documentation that Joanne and Michael were talking about. The team was a lot smaller then, a skeleton crew of 3 brave souls who dealt with a constant barrage of questions in the form of Slack direct messages. As you can imagine, not only was this completely unscalable, it was also really annoying for everyone involved in a few key ways. For one thing, we would end up answering the same questions over and over again in slightly different ways with no easy ways to reference what we had previously said. For another, institutional knowledge was stored in individual people's heads, so if anyone left the company or, went on vacation, the whole house of cards would topple and no one could offer support. And lastly, we got increasingly frustrated when people didn't just use the libraries and documentation we had worked so hard on. In other words, we knew absolutely nothing about service design. Luckily, we have the luxury of having an in-house customer care team who are literal experts at giving support. They taught us how to phrase recommendations in ways that didn't feel so much like mandates and how to metaphorically teach people how to fish for themselves. We also learned from other design systems teams that a single Slack channel isn't a one-size-fits-all solution, which led us to holding weekly office hours and focusing on more holistic system education approaches like onboarding that Joanne described. Our support playbook helps us remember to appreciate how hard it can be to ask questions, especially in a public Slack channel with literally hundreds of people in it. So now, when someone asks us a question, regardless of their attitude, we try to respond with gratitude and thank them for reaching out. After a couple of years of this more drip irrigation-like approach to system user support, we've learned that the vast majority of support requests fall into one of these 3 buckets. So let's try to classify and triage some real-life support questions together. Feel free to shout your guesses at your screen. An engineer asked us, "Hi LPL Mobile, I have a design for a carousel that requires temporarily deactivating the next button and disabling swiping to the next step. How can we implement it in this LPL component?" And they attached this helpful screenshot from the design that they're trying to implement. At first glance, this might seem like option C, a functionality issue, but in actuality, it's mostly option A, a communication issue. Here, an engineer is just assuming that the designs that they're implementing are using the right components for the task, but that wasn't actually the case. In situations like this one, we start by asking a lot of questions. We loop in the original designer into the conversation and a bunch of other teams who are working on similar setup flows. We ask if they've talked to subject matter experts like UX researchers and content designers and try to really discourage silos, especially when all remote work makes that hard. As it turns out, in a lot of cases like this one, once we get the right people talking to each other, the team is able to arrive at a better design using the appropriate components for the task, all without us having to change any functionality at all. Let's see another example. A designer asked us, "Hi LPL Design, I'm designing a simple UI with a main title and some content underneath. Do we have any guidance on what type style I should be using for the title and any of this other circled text here?" You guessed it. This is a classic example of B, a system knowledge gap. We may have previously responded to questions like these with frustration. The answers are obviously in our docs, but this is actually an amazing system education opportunity. In cases like these, we act as human search engines. We can quickly surface the appropriate documentation links and actually beat Google by following up with questions about how usable the documentation was. Just like in the first example, we're able to address these support requests without making any changes at all to the system itself. Lastly, an engineer asked us, "Hi LPL Web, I'm having an issue where this component works fine locally, but then in staging, when you click on the date field, nothing happens." This is actually what most people think of when they think of system support. And if you said that this is an example of C, a bug, you're right. But this is actually a trick question. Even when something looks like a bug, it's often also a communication and/or system knowledge gap. In this case, we looped in a bunch of recent LPL contributors, surfaced the relevant system docs, and all came to a solution together. Regardless of what the problem is, we've really learned the hard way that it's best to approach it with curiosity and gratitude. Whew, we reached the end of design systems. Yay us, we cracked the code. Just kidding. Everything we've learned today is a work in progress, and we mess up literally all of the time. Hopefully, you can learn from our many mistakes and take away some ideas to incorporate into your own systems. Regardless, if you remember nothing else, remember, a system is only as useful as it is usable. Thank you so much for listening, and feel free to reach out to any of us with questions and comments and incorporate some of these ideas into your own systems. Thank you so much.